Welcome to 9.5, talking about tangents today. A tangent to a circle is a line that intersects a circle in exactly one point. So if I take a look over here at circle O, I see this red line, line AB. I see that AB intersects circle O right here at point P in exactly one point. The point where a circle and a tangent intersects is the point of tangency. So point P is the point of tangency. Line AB is tangent to circle O, as we've already stated, at point P. I also have segment PB, that is a tangent, and I could have ray PB, that is also a tangent. A common tangent is a line or ray or segment that is tangent to two circles in the same plane. Here's an example of four lines that are common tangent lines. So if I follow this line out right here, I see that it is tangent to the small circle and the large circle. I see right here this line is tangent to it. I've got another line that's tangent to two circles, and then I have this line that's tangent to two circles. You could think about this as being maybe a chain on your bike or a chain on a motorcycle, some sort of two-pulley system with belts in your car. That's the way I would envision these right here as being common to two circles, so a common tangent. Theorem 9.10. In a plane, a line is tangent to a circle if and only if it is perpendicular to a radius drawn to the point of tangency. Meaning that if I draw in the radius ST here along this tangent line L, if it is going to be tangent to the circle, the radius forms a 90-degree angle with that tangent line. So finding some angle measures here, I have segment ML and segment MN being tangent to circle O. I'm asked what is the value of x. So if I look at my picture, I know because they are tangent and theorem 6.10 or 610 that these two angles right here are 90 degrees drawn in my picture. Again, if you need help, this angle OLM and this angle ONM. And this shape is a quadrilateral. It's not inside the circle, but it is a quadrilateral. And we know that all the angles of a quadrilateral have to add up to 360 degrees. So I have x plus 90 plus 90 plus 117 equal to 360. Now, all you need to do is combine your like terms. So I take 90 plus 117. I get that is 297. So x plus 297 equals 360 degrees. And when I subtract, I get that x is equal to 63 degrees. In the second example, I know that segment ED is tangent to circle O. They want me to find the value of x. So if it is tangent, we know that that angle right here, angle ODE, is 90 degrees. So 38 plus 90 plus x, and again, because it's a triangle, I'm going to set it equal to 180. So 180 minus the 128 is going to be 52 degrees. And you guys are going, where did I get the 128? 38 plus 90 is 128. Now I'm going to subtract the 128 from both sides, and I get that x is equal to 52 degrees. Another common question that they could ask you on these types of questions is determine if the triangle is right. So if I know and decide, is this triangle a right triangle, then I know that the radius will be perpendicular to the tangent line. In this situation, we're going to decide, is LM perpendicular to KL? So, again, we know that the Pythagorean theorem says that leg squared, so 21 squared plus 20 squared. Does that equal, again, we're going to have to try, does that equal 29 squared? So 21 squared is 441. 20 squared is 400. And 29 squared is 841. So I find out 841 indeed is equal to 841. So triangle KLM is a right triangle. It satisfies the Pythagorean theorem. Here I know leg squared, 14 squared, plus 16 squared. What relationship does that have with 21 squared? Well, we just saw that 21 squared was 441. 14 squared is 196. 16 squared is 256. Again, does those, when we add them up, do they equal 441? And this is 452. 452 is greater than 441. So no, triangle XYZ is not a right triangle. If you wanted to be specific, we would say that triangle XYZ is acute. And again, that's just recalling what we know from a previous chapter. So unlike the last problem, they're asking me now to find the length of a radius. So this is going to use some algebra skills. Hopefully you guys could recall some of the algebra skills that you've learned back in Algebra 1. So looking here, I know that my radius is unknown. So the distance from here to here, that's the radius. But if you look along the hypotenuse right here, if I was to extend, that's the whole length of the hypotenuse. So that means that when I write my equation, that the hypotenuse is x plus 16 quantity squared. So that is equal to leg squared, which we know is x squared, and 24 squared is the other leg. For those of you who need a refresher, I'm going to tell you that when I take x plus 16 and square it, that becomes x plus 16 times x plus 16. And now we're going to use the FOIL or the distributive property. I don't care which one you use. I'm going to talk about the distributive property. So this x right here is going to be multiplied to the quantity x plus 16. And then I'm going to use the 16, which is plus 16. It also needs to be multiplied by the quantity x plus 16. So to let you know, x is being distributed to this quantity, x plus 16, and this plus 16 gets distributed here. So now we're going to use the distributive property. We're going to carry on. X times x is x squared plus 16x. And now I got to distribute the 16 to both of these quantities. So I get 16x plus 16 times 16 is 256. Combining my like terms, we get x squared plus 32x plus 256. So that is x squared plus 32x plus 256. 24 squared, we saw earlier, it's 576. And then I have an x squared. So this isn't as bad or as gnarly as we thought it would be. Again, because I have an x squared, I need to subtract that from both sides. Because we were told that if it's a quadratic equation, and again, if it's going to be quadratic, the power of x is 2. So if we have a quadratic equation, we have to have one side set equal to 0. So I'm going to subtract this x squared from both sides, and when I do, we get 576 equals, well, x squared minus x squared, they undo one another. So I'm left with 32x plus 256. Now I'm going to subtract the 256 from both sides. So minus 256, minus 256. So when you do that, you get 320 equals 32x. And now it's a simple division problem. We divide both sides by 32, and 10 is x. So the radius is 10 units long. Looking at the second example of this type, again, I'm going to identify that this is the hypotenuse, so that is x plus 8. This 16 is the long leg, and jk is x, which is the radius. So again, here's my radius. No matter where I go, if I connect over here, that is still going to be a radius. So I need to find the length of that. I'm going to set the problem up. I get x squared plus 16 squared. That is equal to the quantity x plus 8 squared. So x squared plus 16 squared is 256. That is equal to, and I'll show you the work that I'm going to do off to the side here, x plus 8 times x plus 8. That means x times x plus 8 plus 8 times x plus 8. I get x squared plus 8x plus 8x plus 64. So you get x squared plus 16x plus 64. So x squared plus 16x plus 64. That is, again, what this quantity x plus 8 squared becomes. So much like last time, we're lucky. When we subtract the x squared from both sides, we get that 256 is equal to 16x plus 64. 256 minus the 64 is 192. So when I subtract the 64, 192 equals 16x. And I divide 192 by 16. And we get that 12 is x. So the length of the radius here is 12. Moving on to theorem 9.11 or 9.11 here. If two segments from the same exterior point are tangent to a circle, then they are congruent. So in this picture, it's telling me that AB and CB, these segments are tangent to circle D. So then that means that segment AB and segment BC are congruent. So here I'm looking, these segments AC and BC appear to be tangent. So if they appear to be tangent, we're going to assume that they are tangent. So that means that AC equals BC. So 3x plus 2 equals 4x minus 3. I subtract 3x. I add 3. And I get that 5 is the value of x for this one. Looking at the next segment, I see that 5x plus 4 will be equal to 8x minus 17. If you want to write it out, we know that segment MN is equal to segment MP. That's why I set them equal. I'm going to subtract and add, so when I do, you get 21 equals 3x. I divide both sides by 3, and I get that 7 is x. And we are finished. So we could also find the perimeter of these triangles. Again, all these segments have a common endpoint. So if I look, I'm going to highlight to help us out. DB and EB have the common endpoint. So they are going to be 15 centimeters apiece. Here I see that FC and EC are tangent to from the same endpoint. So therefore, they're both going to be 8 centimeters long. And then I look down here and I see that AF and AD are the same. So they are 10 apiece there. So now, to make my life easier, I know that AB is equal to 25. I know that BC is equal to 23. And I know that AC equals 18. I'm just adding those segments up. And when you do, to find the perimeter of triangle ABC, you take 25 plus 23 plus 18. So 25 plus 23 plus 18, that is equal to 66 centimeters. Looking at our next example, things get a little bit complicated, but not too bad. Here I'm saying that the perimeter of the big triangle, triangle PQR, is 88. I want to know what is the length of QY. So if I was to take a look, I know that XQ and QY, those are both segments that are unknown. I'm going to call that X units long. If I come over and look at the next, I know that RY and ZR are tangent from the same endpoint. Therefore, RY is 17. And then I take a look at segment PX and segment PZ. They're both tangent from the same endpoint. So therefore, they have to be 15 centimeters apiece. So looking at finding the perimeter, this side is X plus 17. This side is X plus 15. And our third side is 32. So we're just going to write an equation. The perimeter is equal to the side 1 plus side 2 plus side 3. So 88 is equal to X plus 15 plus X plus 17 plus 32. Combining my like terms, 15 plus 17 plus 32, I get 64. So 88 equals 64 plus 2x. Subtracting the 64 from both sides, we get that x is equal to 24. Pardon me, 2x equals 24. You divide both sides by 2, and 12 is x. So QY is 12 units long. And looking at our third example, again, sometimes we have to work our way backwards. Here I know that CD and EC are congruent. So that makes DC 6 units long. So if that is 6 and the whole length is 16, that means DB is 10. So since DB is 10, that means FB is 10. Now, I also know that AE right here is going to be equal to AF, which is 12. So now all I have to do is add up the side lengths. We should be good. We found all the missing pieces. 22 is the length of AB. We know right here that AC is 18, and we were told that BC is 16. So 16 plus 18 plus 22, that is equal to the perimeter. So when you add those up, you should get a total distance of 56 centimeters. So the perimeter of this triangle, ABC, is 56 centimeters. I hope you have a wonderful evening, and you could find the homework posted on Schoology. Thank you for paying attention today.